Welcome to the Process Simulation Workshop. In this workshop, we'll be examining the dynamic process simulation that was developed based upon the initial part of the simulation workshop. In the first step of the exercise, we'll be changing their slurry flow and examining its impact upon the spray dryer. Then we'll be putting the outlet temperature control into manual, making a similar change and examining the impact, and then manually try to correct for that by adjusting the outlet temperature, and then finally putting the control back into automatic to maintain outlet composition. The process that is being simulated, the spray dryer, consists of the flow to the spray dryer. The outlet, the pressure to the nozzles is an override on the flow control and is there to minimize the impact of overpressurization. The airflow to the spray dryer is simulated. This is mixed with the spray to dry the particles. The gas flow to the air heater is adjusted to maintain an outlet temperature of the air heater, and the flow is maintained through a variable speed drive of the fan. The product moisture is measured and is used in a PID to adjust the target outlet temperature of the heater. So let's get started with our workshop. So we can see this is our flow loop of this slurry flow that is adjusting this. The override pressure control is shown here. The airflow to the spray dryer is there, and the composition measurement and the outlet temperature control of the heater is shown at this point. In the initial part of our exercise, we'll be changing the slurry flow from 6 to 7 tons per hour, so we'll change that, and in response to that, we notice that the outlet of our flow controller is going to the valve. That's because the pressure is below the maximum pressure constraint, and so the outlet, the pressure out is greater than the flow controller output, and the low selector then selects the lower of the two, and so we're able to achieve the target flow that we've requested. In response to that, the temperature and composition is changed, so the temperature is being adjusted by our composition control. As we can see here, at the point where we changed the flow, it had an impact upon the product moisture. That in turn caused the composition control to change the outlet temperature target, and so that's being automatically adjusted. So the change in slurry flow increased the product moisture. That is, it was a wetter product, and it requires now a greater temperature to dry the product. In the second part of our exercise, we'll put the outlet temperature control into manual. So it's no longer going to be adjusted by the composition control since it's in manual. We'll make a similar change in our slurry flow. In this case, we'll go back to original target of 6 tons per hour. So we're reducing the flow of material to the dryer. And as a result of that, we see that the composition is changing. In this case, we're getting drier because we have less product or less input to the dryer with the same amount of gas flow. So we can better see this in our chart, as we see at the point where we reduce the flow to the spray dryer. The composition has actually gone down in terms of moisture content. As an exercise to demonstrate the benefit of automatic control composition, we'll change the outlet temperature to try to guess what is required to bring our product moisture back up to target. In this case, we made a change, and as a result of that, we noticed that the composition is coming closer to target, but we guessed wrong, and therefore we didn't achieve the target value. It's a lot easier just to let the outlet temperature be adjusted automatically, and so we'll put the outlet temperature back into Cascade so that the composition control can be adjusting the target outlet to maintain the product moisture target. So as a result of going to Cascade, the composition control is now adjusting the temperature. As we can see here, the outlet temperature has been changed to bring our target composition, our composition up to target. And so we can see that as the temperature is adjusted, then we come right in on target, as is shown numerically in the very bottom part. The trend of the composition is a little bit tough to see here, but if you look at the numeric value, you can see we're right back on target. We hope this exercise has been helpful to you in terms of examining this dynamic simulation and the controls that are demonstrated here, as well as the process simulation. We hope you'll use this dynamic simulation and the controls to examine the behavior of the spray dryer under different conditions by changing target values and modes of the different control that is included for this process.